Bonjour à tous, bienvenue au séminaire at SystemX. La présentation va être en anglais, donc je vais continuer en anglais. So, good afternoon, everybody. I'm Jeremy Sabaliauskaite, research engineer at the Institute SystemX. Before the presentation, I want to thank you, Christina, and the communication team for the organization. And thanks, Patrice and Lilia, for the invitation of Giedre at the seminar. And thank you, Giedre, for coming at this session of seminar at SystemX. And I will just make an introduction of you. So Dr. Giedre Sabaliauskaite is an associate professor in Assured Autonomous System. She is part of System Security Group at the Institute of Future Transport and Systems at the Coventry University. She received a PhD degree in software engineering from the Osaka University in 2004, following our bachelor and master degrees in information system from the Kaunas University of Technology in Lithuania. Before, she worked for over 7 years at the ITRUST Center for Research in Cybersecurity at the Singapore University of Technology and Design. And from 2016 to 2020, she was a principal investigator of the Autonomous Vehicle Security Project, where she worked on combination of safety and cybersecurity for the autonomous vehicles. That's when we contacted her during the exploratory research on hybridization of safety and security for the design and validation of the autonomous vehicle with Martin Boyer and Théo Cholin. During this seminar, Giedre Sabaliauskaite will present the subject integrating safety and security for cyber-physical system, followed by a question-answer session. So during the presentation, you can put your question on the chat tab, and Giedre will answer at the end of the presentation. Thanks again for coming, Giedre, and I'll let you begin your presentation.
Great, thank you. Thank you so much, Jeremy, for nice introduction, and thanks everyone for your time, for being here, and thank you all organizers for making this happen. It took some time, but I'm very happy to be here and to present today. Okay, so let's begin. So as Jeremy introduced me, I'm Giedre. I'm currently from Coventry University, UK. And today I will talk about one of the challenge, which is integrating safety and security in cyber physical systems. Okay, now, I forgot. Okay, it looks like this. All right, so before I start with the topic, let me introduce my team. So I'm now a member of System Security Group. We're the team of 5 academics under the leadership of Professor Siraj, and we have a group of researchers to support us, and also more than 10 PhD students. And if we would need to describe what we're doing with one sentence, it could look like this. So this is our mission statement. So what we do is we do research, mainly research on security, safety, resilience of cyber physical systems with application to automotive and transportation domain. And we work in collaboration with industry, academia, and government. Okay, now to give you an example of the type of research we're doing, with a couple of projects. So the first one is Secure Cab, which looks at the security of connected automated vehicles. And this one is developing solutions for hardware level protection, for anomaly detection at the very low hardware level of the vehicles. The second 5G CAL project is more transportation system level project. It looks at the self-driving trucks and their remote operation using 5G network. So we have many partners in this project, which are developing different parts of the system. And Coventry University is in charge of making cybersecurity analysis of the entire system. Okay, so now let's start talking about safety and security integration. So first I would like to introduce the definitions of what do we call safety, what do we call security, because maybe some of us are not familiar with these terms. So in general, these are two critical properties of so-called qualities of a system, which are dealing with minimizing risk of some undesired, unwanted consequences. So safety is dealing with all bad things which could happen accidentally, so any kind of failures in the system, while security is looking at the intentional attacks, which can be physical or cyber attacks. So physical happens if somebody gets access to the system and damages it intentionally, while cyber attacks when you do it through a computer-connected device. And both of these qualities are interdependent. Sometimes they complement, sometimes they conflict each other. So today we'll be looking into that part of their relationship. Okay, so first I would like to think of examples from nature where safety and security are well integrated. So for example, for me, sea turtle looks like a good example because it has this hard shell, which protects it from any crashes, accidents, but also if somebody tries to intentionally attack it, it's quite protected. It can live in the sea, can live also in the dry land. It's a bit slow, so performance is not so good on the dry land, but besides that, it's quite safe and secure, and also can live for several years. So this is one could think of example and after we can discuss. Okay, then let's think of in practice when safety and security are in conflict. So the first one is example of the fire escape. So with stairs, which can be used if there is a fire in the building, so it lets you escape. So it is there for safety reasons. But by putting these stairs there, we are worsening the security because then we are allowing some unwanted access to the apartments, which is not what we want to achieve. Example is oh, excuse me, I'm checking the chat, and there's some people. Can you hear me well?
No, we have some difficulties to hear you. I don't know if you have a problem of the connection, but
let me try to disconnect and connect again.
Okay.
Okay, how about now? Can you hear me better?
I think for the moment it's better, yes.
Okay, so it will be better if any, just let me know.
No,
okay,
no,
so
I think
forward.
no problem again. Yes. Are you on Google Chrome or you use another browser?
I'm on Safari. Should I use Chrome?
Maybe it can be better, yes.
Could it be better?
Yes.
Okay. Okay, so I will then disconnect from here and I will reconnect with Chrome.
Okay, let's try. Yes.
Okay. Okay, so I tried to reconnect from Google Chrome. Could you see me there?
Yes, I think it's better for the moment.
It's better.
Yes.
Great. So let's hope it will stay that way. So,
Yes.
so let me continue. I will switch off camera, so maybe that will improve the communication. I will just keep the microphone on.
Yeah. Yes.
Okay. So today I would like to focus on 3 questions in this talk. So question number 1: how can we identify the relationship between safety and security? Second one: how can we capture the information of these relationships? So once we identified the relationships, how can we then put it somewhere in some model, into some list and something that we can use it later for analysis? And the third question is, how can we solve the conflicts between safety and security? So let's say if during the first 2 steps, if we identified that there is a conflict, so what can we do to solve it? So this work I will present today, I will present several models, and most of them were developed while I was working at iTrust Center in the Singapore University of Technology and Design. Okay, so question number 1: how can we identify those relationships? To do that, first we needed to look at the available models for safety and security modeling. So the most simple, one of the simple models for on the safety side are fault trees. So basically take one failure, which we don't want to happen, and then we analyze it by dividing it into sub-failures and even lower level failures until we have clear idea of all the failures which could lead to this high level failure. So we have very basic elements. We have nodes, which are failures at different levels. We have gates, could be AND or OR. And we have the edges, which connect failures between themselves. Then on the security side, we have a very similar model, which is attack tree. And it also shows the attack path through the system. So what needs to happen, what attacks need to happen to lead us to this high-level attack. Then conventionally, in practice, safety and security analysis is performed independently. So on the left side, we see the failure analysis done for safety. So we construct the fault trees, and even we can attach the safety measures to see which measures could be useful to deal with some of the attacks. Some of the failures. And on the security side, we form attack trees and we attach countermeasures, and we see what is this overall picture of attacks which could happen in the system. So our question was, could we try to combine these models together into one model? And we did exactly that. We proposed a fact graph, which is failure, attack, and countermeasure graph, which incorporated attacks from the attack trees and failures from the failure trees, and also it added the safety and security measures into it. So what we get with this model, we can see a complete picture of the weaknesses of the system. So we can see, for example, what some malfunction could happen, and it could be a result of a failure or of the attack, and no measures we can use to mitigate it. For example, measures at the higher level, so then we can decide that we don't need measures at the lower level, as the system anyway will be already protected. Now this work, I will not go into many details, but if somebody wants to know more, I included the references to the papers where this work is published. And as I will be describing other models also, most of them have the references. So just please, if you need more information, just look there, and you can always contact me if you want more information also. Okay, so let's say, so the fact graph was actually quite useful method, and it was applied in practice, and at least the people we knew were applying were quite happy with, because it was easy to use. It was very somehow simple. But then we thought, well, we need something else which will allow us to capture all the information, so to help us understand how things are interrelated within the system. So what can we use for that? So first of all, because we're dealing with a cyber-physical systems. And cyber-physical systems are complex systems. They integrate with the computer systems, the physical system, also the communication networks. So first we need to understand how can we model such complex systems. So we started looking into what is done in complex system modeling. And we found a model called GTST, which is Goal Tree Success Tree, developed in the 80s. And it basically, what it proposes is to structure the system into hierarchies of different things. So we propose to make a hierarchy of functions. So basically, we start with the main function, which is the goal. And then we can divide it in sub-functions and so on until we get the very low-level functions. And we can do the same with the system components. So we start with the entire system, then we can subdivide it into subsystems until we reach the very low-level components. And that will help us understand how systems are built, basically. Then in 1999, Modares and Chan decided to extend this model and to add a matrix. They called it master logic diagram, which matrix basically interconnects functions with components, with systems. So they say, like, if we want to implement this function, we need this and this component. And yeah, this was quite a useful tool back then. But then, 10 years later, another author decided to extend it even more and to add failures. So as we see in this figure, we added failures in the bottom, and they could link the failures to the components and also to the functions. So that this was used for safety analysis. It showed that, for example, if this failure happens, so then it will affect this and this component and this function. And then it was easier to understand what is the effect of failures on the system. Okay, so we liked the idea and we thought, let's try to use it for safety and security analysis. But before to do that, we needed to understand very clearly what hierarchies are there related to safety and security. So in this three-step model, we already had the functions, components, and failures. So we took those three, functions, structure, failures, when we also added attacks because we needed something from a security side. And we thought also that safety and security measures are important hierarchies to be there. And then we understood that actually all of them are interrelated within the system. So for example, if we take failures, so failures means that some components have failed or some connections can fail. So they're related to the structure. Then the failure will attack the function. So also there is a link to the function. Then some attack could lead to this failure. So that's why we have a link between attacks and failures. And there are safety and security countermeasures, which could help us to mitigate the failure. So once we're happy with the hierarchies, we started building our model. Obviously, just the timeline, so just to show how the model evolved. So it started from 1999, then failures added in 2009, and finally we added 3 more dimensions. And this is the structure of a 6-step model. So as we see on the left side, we have all the hierarchies. So we have functions, structure, failures, attacks, safety countermeasures, security countermeasures, and we have all these relationship matrices which are formed in between of them. So in total, we got 6 hierarchies and we got 21 relationship matrices. So it was quite a big, quite a complex model. And then we tried to implement it on the automated vehicle, and this is the example of a 6-step model. So as we can see, it becomes quite complex, and it would be good to have a tool because you cannot build it manually. It's not possible because systems are very big. And then we had some difficulties. So we tried to develop a tool, but because it requires 2 types of information. So we have this graphical information, those trees on the left side, and also we have the tables, the matrices. So wasn't an easy tool to build. And another issue we had that it was still, we couldn't clearly define all the relationships because we understood that we need different types of relationships. And also it would be good to have not just qualitative relationships to say which is, strong relationship or medium or there is nothing, but it would be good to add some numbers there. So, well, we couldn't complete the method, so it's in a concept phase, but I believe it's a good one, so hopefully one day it could be finished. Okay, now let's think how could we solve conflicts between safety and security. So like I explained it in the very beginning, sometimes could be that we implement some measures for the safety and then we negatively affect security and vice versa. So what can we use to solve it? Well, to do that, first we need to understand which one is more important. Is it safety more important as it relates directly to the harm to the person? Or is it the security more important because it includes safety, but it has all these additional aspects like financial, privacy, operational. So which one could be more important? And if you ask safety people, they would say, of course, safety. And you ask security people, say, of course, security is more important. So actually, we came up to a conclusion that none of them is more important. They're equally important as they're there to implement business goals. So they're at the same level. And if a business goal is saying that we need to reach this level of security and this level of safety, so it means we both need to be there. And then sometimes we can do that just by changing the measure. So for example, let's say we have some measures selected for safety and say, okay, this contradicts with security, so we just choose something different, and that's okay. But sometimes it happens that it's not possible to do it, and then it's necessary to redesign the system. Okay, so then we thought, we need some method which could be used for making this decision to how to solve this problem or this conflict, which would help us to find a way. So we started looking at the management, at the methods used in management for decision making, for making things more effective, reducing cost, and so on. And we found this quality function deployment method, which was proposed long ago in the 60s in Japan. And the purpose was exactly for that, to have some method which helps, an easy one, which helps to make decisions, basically to balance things within the system. So how it works, we have two types of variables. So we have dependent and independent. Dependents are the what, and they put as rows, and dependent are put like columns, and then we form a relationship matrix between them. But in addition, we have these attributes. So on the right side, we have attributes of all these rows. So additional information which could be useful for decision making. And at the bottom of the matrix, we have additional attributes of the columns. And then these ones can help us to understand. So we can put there different things like what is important for the system. Could be cost, could be time, could be risk level, could be anything which is important. And then based on that, it helps us to do things, to make decisions. Then it's not only one matrix, so there is like the sequence of matrices. So first we start normally with customer requirements, and we map them on the design requirements for the system. Once we're happy with selection of design requirements, we can map on some engineering design requirements and so on. And we go anytime deeper and deeper, defining things, but we can keep the track of decisions. So at any time, we can go back and see why did we choose this? Why did we choose that? And also if we change anything, so then we need to go back and to check things. Okay, so we thought it's a good idea. We could try use something similar for safety and security analysis, for this conflict analysis. But then we want it to be a useful method, so we decided that we make it compatible with the standards. And at that time, we were working on autonomous vehicles, so we looked at the autonomous vehicle safety and security standards because we wanted to understand which variables should we use, which are being used in those standards. So let's say if companies try to apply the standard, then they can use our method to help them to analyze things. So let's look at this figure. On the left side, we have a vehicle life cycle. So it goes through a sequence of stages. The first one is concept phase. When the concept of a vehicle is defined, some architecture, some high-level requirements. Then we go to product development, where the product is developed, so hardware, software, integration, testing, all done in product development phase. And then we go to post-development, which includes production, operation, service decommissioning, all that type of phases. And then we identified the activities, the safety and security activities. So we start with item definition. Usually we define the part of a system which we want to analyze. And then for that part, safety and security goals are specified. These goals are very high-level requirements. Then they are transformed into the more detailed requirements, and even going down even in more detail, system-level requirements, and finally hardware and software-level requirements. Now, what is the requirement? What is safety requirement? What is cybersecurity requirement? So safety requirement usually includes a hazardous events or failure, which we want to mitigate. Then includes safety measure, and also its allocation to system components. And cybersecurity requirement is very similar. It has the threat scenario or an attack. Then it has security measure and also has its allocation to the components. So we decided we could, if we want to stay close to the standards, we could use variables such as requirements, measures, and components in our model. And then we did exactly like that. So we tried to form these QFD-inspired quality function deployment-inspired matrices for our purpose. So first matrix is mapping of safety and security requirements on requirements. So the idea was to try to identify contradictions between them using different parameters which we can paste on the right side and the bottom of the matrix. So to solve, basically to solve the conflicts between requirements at a very early stage. Once we're happy with the list of requirements, we move to the next matrix, and then we assign safety and security measures. So this is quite useful one, because if we use this matrix, we can see that, for example, some measures can be assigned to several requirements, so we don't need so many measures. We can use them more somehow efficiently. Once we select measures, again, we need to see are there any contradictions between them. So we go to a matrix 3, where we analyze the relationships. And finally, once we're happy with the selection of measures, then we go to the final one and we assign them to the components. So this work, the very first results of this method are already published in a conference paper, and down is the reference. Okay, next thing we did, we thought, what if we put all the matrices together in one meta matrix so that it can be used later in the development lifecycle, even after we already finished development? So, for example, if we're talking about the vehicle, so vehicle is already operational, so it's being used. And we know that, for example, for automated vehicles, it's necessary to keep them updating all the time, especially from the security side. So if there are any new types of threats discovered, so we need to update the vehicle, so to make sure that it is protected and no harm can be done. So for example, if we have a matrix like this, it can help us do it. So let's say if a new threat is detected. So first thing what we will need to do is to look at the requirements and to see if such threat has been already considered among requirements which are implemented in the system. And if it has, so we can check in matrix 2 if it has attached measures. And if yes, so then we are sure that we are protected and we don't need to do anything else. But let's say if there is no, it has not been considered. So we can use it then, we add it, and we check relationship to other requirements in the matrix 1. Then we go to matrix 2, assign the measures, make sure there are no contradictions between measures in matrix 3, and then finally assign the components where it will be implemented. So we think that this could be a useful tool, especially at the later stages of the system development. Okay, and I think that's all models I wanted to show today. So let me quickly summarize them. So this is the journey we had so far with development of models, which shows how did we move from one model to another. So we started with a fact graph, simple graphical model, which helped us to identify the interrelationships between safety and security. Then we needed something bigger to allow us to capture all the related information. That's why we combined the graphical model with the tables, and we defined a 6-step model. Then we needed something to help analyze, especially to analyze conflicts, because 6-step model was a very good model to capture information, but it didn't really allow much analysis to be done. So that's why we defined our third model, which is safety and cybersecurity deployment model, or with the QFD-inspired matrices. And what are we doing now? Actually, now we're continuing refining those matrices to make them more practical, so to be a practical tool for trade-off management along the complete life cycle. And also we're looking how could we integrate human factors into this new model. Okay, at the very end, let's look at the bigger picture. So in general, what models are being developed, how many out there, why do we still need more? So I found one recent survey paper, which was published last year, and it's a survey of cyber physical systems safety and security co-engineering, so integration, basically models, methods, and they found 6 to 8 methods available so far. So why do we need more? What's still missing? So they identified several challenges. One challenge is that still is difficult to find models which are compliant with standards. Some models are good, but they're limited to application domains, so we cannot easily move them from one domain to another. Still, there's a big lack of quantitative approaches, so most of them are qualitative, not quantitative. One big problem is tool support. So even if there is a nice method, nice model proposed, but it's difficult to develop a tool which would help implement it. And yeah, there are human factors which have to be considered, and there is need of more guidance in the models. So the final part are takeaways. What takeaways you could take from this talk? So I like this saying that the new is a well-forgotten old. In my case, I always like to look back. So if I want to develop something new, I try to look back to try to find inspiration, basically what has been developed, and to get ideas how it could be improved, how it could be used. So my advice would be when you want to develop new method or model, first have the purpose of it very clearly defined. So for example, if we say we want to develop a method for safety and security integration, it's not enough, it's too broad. You need to look exactly what problem exactly we want to solve with this new method, and only then to look what could be used to do that. And I think, yeah, the two requirements which I think are very important for any method which is being developed is first for it to be compliant with standards. So to use similar terminology, similar definitions, similar variables which are being used in standards, so you can use in your tool. So then people who can use your method to comply with standards. And the second one, that if you have a tool which helps you to build models, then it's very helpful. Then it will be much easier to implement it in practice. Yeah, and yeah, always we need a bit of luck. So good luck in your research and the works are developing. And thank you very much for your attention. Now I'll be happy to answer any questions you have.
Thank you, Giedre, for the presentation. Is there any question? I have a first question about the 6-step models. How do you define relationship interdependencies? Is there a methodology for this, or it depends only on safety and security experts?
I think it very much depends on experts, and we couldn't finalize it. So first we thought that for some things, for example, for the coverage of, like, let's say if we have the countermeasures, right? We can use some coverage. So this measures cover some failure or attack completely or partially. Then another type of relationship was, for example, between the measures. So we have to look what kind of dependency. Do they reinforce each other? Do they conflict each other? So we need already a different type of relationship. And so on. Then, for example, for the, let's say, relationships between functions and components, so then that some component is necessary or is important for implementing the function. So on. So there are different types of relationships. Then it's necessary to be very specific about different types. Then once we have types defined, then how do we categorize? If we use just strong or weak or medium, it's not enough. We need to be more specific. Then after we tried hard to solve this puzzle. We didn't finish because after even we reached some things like the direction of the relationship. So see, for example, we have let's say we have a security measure, and this security measure is to protect some component. So we need to put relationship that this measure is related to this component. But then sometimes this security measure is implemented in some different component in the system. So for example, we're implementing some measure to protect sensor reading, so it's related to sensor, but we actually implemented somewhere on board computer. So also we need to show this relationship, but these are different things. So how do we show that? So finally, we couldn't. It's not solved. It's not finalized. I hope it will be, but there's still a lot of work to be done.
Okay. You have a question of Mohamed Lee. Read the question, but you can see it. How do you manage to treat safety and security at the same level, knowing that from a safety point of view, we start processing at the operational and functional level of a system, while cybersecurity is more interest in the component of the system to establish security policies?
I think, well, if we look at the security, I don't know for other types of cyber physical systems, but I know more about the automated vehicles, as I'm currently working on them. So in the vehicle domain, if we look at the security, so security issues can lead to 4 types of losses, so 4 types of damage to the system, which we're concerned with. So it can be safety losses, so attack can lead actually to some safety loss, or operational, financial, and privacy. So in this sense, security includes safety, but it includes additional things. But it doesn't include these parts of security, of safety, sorry, which are not reachable by cyber attacks. which can happen just because of some accidental failures. So we cannot say that safety is more, because yeah, safety looks at always safety, but security looks at safety and other things. So I think that's why it's a big discussion. And in my case, at least me personally, I prefer to see them at the same level, because there are some higher level goals, some business goals, which if we say that, you know, we need to address all the security issues, so that has to be done. And if we say we need to address all the safety issues, also have to be done. So they're at the same level, in my opinion.
Okay, thank you. Next question of Pierre-Marie. Do you think the gravity evaluation of failure and attacks can be used to solve conflicts between safety and security measures?
Could you explain a bit more? What do you mean?
Pierre-Marie, I'd let you ask your question. But we can go to the next question. Of Michel Watteux, can you talk about the differences between safety features and cybersecurity features? Because you introduce the notion concept of event for the safety point of view and scenario for the cybersecurity point of view. And these two concepts are generally not in the same level of abstraction and not handled with the same theoretical tools.
Let's go back to the slide. So if I understood this, it's about this slide, right?
Yes. Yes.
Okay. So
maybe.
Okay. So then, so we have these activities, right? And so the very first step where high-level requirements for safety and security are defined is specification of safety and security goals. And at this level, the hazardous events are defined and threat scenarios are defined. And the risk levels are determined. So at the same level, we make analysis for safety and for security. So analyze threat scenarios, we identify the risk level, and we also analyze hazardous events, and we define the risk level. So we're at the same abstraction level. When we go down, then we specify requirements. So already attach the high-level measures and allocation to architecture. Again, it's done at the same level. So if we put those standards side by side and see what are the activities, what level of analysis, so it's quite the same. They can be, because safety standards have been developed first, and then based on that, security standards has been developed, trying to follow the same process. Because idea, I think, in some years in the future, maybe they will be merged together into one standard. It's going in that direction, but until now, they are kept quite similar. So I don't know if that answered the question.
Okay, thank you. About the question of Pierre-Marie, the precision. What I mean is that in ISO of cybersecurity and other risk analysis, you evaluate the gravity impact of an event like to determine its risk. If you have a conflict between the safety and security countermeasures, can we look at how high the impact or gravity, the failure or attacks they are trying to solve, and choose the one with the higher impact as a priority?
Sure, that we can do. It's like I said, in those matrices, when we put them, for example, relationships, and then we put this additional information on the right side and the bottom. So the impact could be one of these additional parameters which help us decide. But I think that's not enough. For example, let's imagine we have, so let's say safety requirement is with, let's say level 4 of impact, and security with level 3. So then, yeah, if we follow this suggestion, so we just take the safety requirement implemented because it's higher level. But there could be some higher level, like I said, various business requirements. So higher level requirements will say all the safety and security requirements with risk level, with impact level more than 2 have to be implemented. So if we have such a goal from above saying we cannot just eliminate one of them because it's lower than the other one. If both of them are higher than 2, so we have to implement both, and then we have to find a way to do it. And like I said, sometimes we can just change. So we select different security and safety measure, and we say, oh, okay, actually we mitigate the risk and they don't contradict anymore, and we're okay. But sometimes we cannot, it's not possible. So then we need to redesign the system to make it possible.
Pierre-Marie wanted to add something.
Oh, I see.
Okay. He said, I don't want to eliminate one. I propose that the lower has to devise the countermeasure with the constraint of the safety countermeasure.
Yeah, sure. I mean, it's necessary to think that there is no one valid answer, because like for different systems, there are different goals. What do we want to achieve? And so, for example, some developers can decide one list of parameters which are important. Another developer can decide a completely different list. And that's totally fine. The idea is to have this very flexible tool which fits your needs. So based on what you want to achieve, what are your requirements, you can fill it in with information and it can help you to solve the issues.
Thank you, Pierre-Marie, for the question. Next one of Samuel. Thanks a lot for the very interesting presentation. Naive question for security attack elicitation. In safety analysis, it's possible to elicit safety failure modes on function with some kind of what-if approach. List of standard failure modes for function not available, stopping, starting when not requested. There exists a similar systematic approach for security, maybe related to interfaces.
There are many approaches with times. For example, there is some piece of work we've done in Singapore. We haven't published yet, but we looked at this STPA, which is System Theoretical Process Analysis, which can be used for safety and for security. We analyze, there is more, we look at the system as a process, and we look at what information needs to be received, processed, and sent to another component, let's say to another system or subsystem. And we look at this information, let's say what happens if it's received too soon or too late, or it's incorrect. And then we try it from there to go into, to analysis what could lead to that. So, yeah, and there is a lot of debate. So some researchers think that we could try to integrate, really to analyze safety and security together. So we developed some good method which helps us to do both. But I would say no, actually it's not possible, because if we put them together, then we lose some important information which is just important just for safety and cybersecurity. So we should keep them separated. So I think for now there are a lot of methods, a lot of suggestions. There is still no agreement how to do things. A lot of people propose different ways, but I think it's okay, because in the end all the systems are different, and also we should not forget that all the people working with systems are very different. So different methods work well or not so well, depending on many factors. So it's okay to have this variety of tools, of methods to choose from.
Okay, thank you. Next one of Reda. What I know as a cybersecurity specialist, safety is all about hazard, which is known at design phase, or at least most of it. At the cybersecurity level, threat is partially known. What about the unknown unknowns? I'm not sure that we could be able to capture them, and most importantly, solve conflicts beforehand. How to prevent that new patch, security update, will not conflict with safety properties?
Yeah, that's a very good question, which is actually now with the standard is being developed already. The first version is released. How do we deal with software updates? So for vehicles, for example, some over-the-air updates are proposed. That server's process is defined. How do we update the vehicle in safe and secure way? Because as we know, the attacks will continue being discovered, new types of, because, you know, like I said, failure depends on the system. So we know the system, we know how it can fail. So then we can try to understand and to predict and to mitigate all these possible failures of the system. As we know, it has a boundary. So safety has a boundary. But if we look at the security, there is no boundary, because it always appear new ways to connect, to attack, to do things, and these attackers are very, very creative people. So then what could help? So that's why we came up with this model, which I'm showing, this model 3, safety and security deployment model. So this was thought to be useful in exactly the same situations. For example, if we have a new attack, it hasn't been considered. So then we define the requirements. So we define that we want to protect the system from this attack. And then once we do that, we make sure that it doesn't cause any conflict with the existing requirements. Once we're okay with matrix 1, then we move to the next. We try to assign maybe some of the existing measures actually are already can be used for the same attack. So if that is the case, we're okay, we don't need to do anything else. If not, then we need to include additional measures. And to do that, it's very important, we need to see if there is no contradiction with existing measures in the system, which were, you know, safety measures especially, they were already defined long ago in the development phase. So that's why we use this matrix 3 and solve all these issues, and then we see how to implement that. So yeah, there is a need of this type of models which help to make analysis after the development is over, because exactly like you say, safety stopped at that point. At least most of the safety implementations, most of the safety issues have been already resolved at that point. But now some of the, if we try to introduce new things to address the security issues, we may cause some conflict with existing measures in the system, and that's why we need to be very, very careful there.
Reda answered that he said that I didn't see how you verify that new requirements are not conflicting with old ones. Is it a human process or tool-based?
Sorry, once again, I didn't quite understand. Oh, I see how. Yeah, that's a good question. How do we see them? Sometimes we cannot see the conflicts if it is high-level requirement, because, you know, like I showed, there are different levels. So when we have very abstract requirement, we just say we need to protect system from such and such failure or such and such attack. And then at that stage, there is no conflict. So we need to do two different things. So we cannot identify it at that phase. But if we have a very detailed requirement, so at the lower level, so the requirement definition already includes the measure. So the measure is assigned inside of a requirement, and even have allocation. So there is allocation to a component. So if we go to a very detailed level, we have more information in the requirement specification, then we can see that there is a conflict, because there is a conflict between measures. which are included on the requirements. So with matrices, we can be, we don't put everything in one, they can be used at different phases of the analysis. And we analyze things based on information we have. And sometimes we can, like I say, sometimes we can already identify. If it's a very low level requirement, then can easily, not easily, but it's possible to identify the conflicts. Because if, for example, if we see there is a conflict between measures, right? So that means there is a conflict between requirements which include that measures. So sometimes we can do that. But sometimes, yeah, sometimes we will not be able to do that.
Thank you, Giedre. Thank you, Oda, for your question. Next one of Lutfi. Thank you for the presentation. I would like to know how do we protect sensitive information and load and store by third-party vendors, knowing that employee are still the largest security risk. Thank you.
Oh, so sometimes, you see, sometimes we have these technical solutions. So always know, well, let's say if you look at the vehicle, so we implement some security measures in the vehicle and we make it protected. But like I say, there are people involved, and sometimes, not always, we need a technical measure. Sometimes there are, for example, procedures. So it's a procedure, so some kind of law, a requirement defined by companies saying that, you know, all the information should be stored like this, and just the authorized people should have access, and they will do this and that. So we can, so there are different types of security measures. So for handling sensitive information, there is a procedure which has to be followed as well.
Okay, next question. 4 questions of Witold. The first one: do you have an from the practitioner point of view? Do you have an experimental tool or plan to develop one? What kind of quantitative result can you expect from your model? Is it possible to use your approach for optimization or sensitivity study? And what is an effort of adjusting 6 matrices after the system architecture modification or after the discovery of new vulnerabilities?
Okay. Oh, that's a lot of questions, but nice. Thank you. Okay, let's start with the first one. Do we have experimental tool? No, we don't have a good tool. So for example, the last one for this type of matrices, so they can easily be implemented in Excel. So what we did so far in experimentation, we just used Excel, but we don't have tool for that. Now for six-step model, we tried hard to develop a tool, and how can I say, we failed because we needed more time, and it was part of a research project with the government. So we had tight deadlines, and we needed to propose something more practical. So we couldn't finish. So we don't have a tool for that. Yeah, and for the fact graph, we don't have a dedicated tool. Yeah, we tried to. There is a open source attack tool. I think it's T-tool. And we were negotiating with developers. They said that it's easy to extend the tool and to include failures and countermeasures, but we didn't finalize, so it is not done yet. So the short answer to this question would be no, we don't have yet. But I would like to develop something, especially for these matrices, because yeah, one is we can always use Excel, but maybe a dedicated tool could also help. So then the user don't need to start creating the tables, but maybe can be some templates, some kind of some help there to make it easier. So actually, now I'm looking in how to improve this one. So if it works and if it goes as expected, so we applied for research funding for this research. So if that happens, so then tool development will be part of that work. Okay, now what kind of quantitative results can we expect from the model? Okay. Well, it always depends. What do we want to get? For example, for now, we want to have this tool which allows us to manage trade-offs. So when we need to to balance safety and security. So like was one of the previous question, if let's say if we say that we want to have let's say the best list of safety measures which satisfies all the requirements and which is the cheapest, or we want the most effective list of measures. So let's say if we want maximum protection, so we should use this and that, or we should, so we can, the idea that we should put what we want to achieve. So somehow what we want to achieve is selection of safety and security measures, and then the tool would give us an answer. So saying you should, do this and that. So I think that would be a useful result to be given by a tool. Yeah, is it possible to use an approach for optimization sensitivity study? Which approach, which exactly one you are referring to? Is it a 6-step model? Is the latest one with matrices? And then what's an effort of adjusting matrices after system architecture modification? Well, there's always an effort. That's why we tried, let's say, in 6-step model, we have so many matrices, we have more than 20, and we understood that it's too many. If something changes, we need to go and change information everywhere. So if we had a tool, for example, a tool could at least highlight to us saying, you change something here. So let's say we change one component. So this tool could say, well, then you should look at this and this measure because related to this component, should look at this and this function. So to see if anything, so if we would have a dedicated tool, it could show us, could point us to the things which could be affected and would be easier to find that. But if there is no tool, if we need to do it manually, so of course it will be incredible amount of effort. So that's why for complex models like this, tool is very important. So I hope I answered the questions.
Yes, thank you, Giedre. Thank you, Vital, for all your questions. Is there any other questions? I have just a question about the 6-step model and safety and cybersecurity model S and SC. Yeah. So in slide 31, yes, the SCSD model, is it an improvement of 6-step model, or this is not the same objective? Because in the AVAS framework paper, you said that 6-step models is more complex than SCSD. And I wanted to show what are the differences between the two models. I don't see the real difference.
So I think the relationship matrices, so we could use exactly the same which we have in 6-step model. We can use an SCSD model. There's not a big difference. I think what makes it different is this it allows us to add additional parameters to each matrix. So we can use not only information contained within the matrix, but also around. And that becomes more useful. Then we can play with that information, we can make decisions, we can do things, we can do more things. Because if in 6-step model, if we have a matrix and just shows that this and this is related, but sometimes we need additional information to know what to do next, and we don't have it there. So that's why, so now this SCSD model, again, which is published in the Aves paper, is, because it was just the introduction into the model. Mm-hmm. And it was, you know, always when you make write the first paper is not so good as you have to come up with the better ideas. So what I can tell now that actually now I'm working on the improved version, more detailed version, which I'm planning to publish as a journal paper very soon. So once it's done, I can share the draft so that it will be more clear how these are different and how this one is more simplified and easier to use than the 6-step model.
Okay. Thank you. Okay. Another question of Arthur. Do you find the safety security conflict is more of an inherent problem or rather a consequence of different approaches?
I think sometimes it's not intentional, just it's different points of view. So let's say like was this example I showed in the beginning with fire extinguisher. So safety people think there is a fire, we need a fire extinguisher, so we put it there. So in case of fire, we use it. But security people think, oh, but it's something valuable, it can be stolen, so we better lock it. So they just lock it. And then, you know, we don't see a contradiction until it's too late, until the fire happens, and then we cannot open the cabinet. So sometimes also happens, for example, in other systems, that we have some, how can we say, for example, we want to put a lot of security measures to authenticate, to, you know, that for people to access control and so on. But those things sometimes can slow down the system, can use too much memory, can make processes longer, and sometimes because of that, we can cause some safety problems, which security people are not aware of, because they just, like I think, they look at the things from two different perspectives. So that's why it's important to have some point in the development when, you know, we put them together, and when they show saying, okay, we're planning to do this for safety and we're planning to do this for security, and then they look at everything and see, oh, actually we could have a problem here. So it's necessary just, so it's not intentional. This is just two different perspectives to look at things.
Okay, another question of Kevin. You consider that both safety and cybersecurity are equally important. As a safety engineer, it seems that whenever safety and cyber interact, you usually fall into the following situation. Cybersecurity provides additional elements to safety that reinforce the completeness of safety studies, but it seems like a one-side contribution in favor of safety. The question is, do you have additional guidance of how to better balance the relationship between safety and cyber to be in an equal footing?
Yeah, I think we're reaching this point when we cannot look at the just technical solutions. Because we can develop many models and many methods, but, you know, people need to use them. And if people don't like them or don't think they're useful or important, so they will not do it. So I think we should really start looking at the human factors, so human side in all this. So the main thing is to make safety people to understand security people, and together to try to look for some common solution. That's why other direction of research I'm trying to follow is to look at the human factors. So how do we incorporate humans in all this? Because safety and security events are implemented by humans, so we need to consider it, and we need to find a way to address that side. So if we both think that if let's say we need to make safety and security people talk to each other, so if both of them think that they are more important, they're higher, so we'll be just fighting. There will be no listening, no conversation. But if we need to both understand that at the same level, and they need to find a common solution, so only then they can try to do something. And I think for now it still is a fighting. It's like who is more important. So it's difficult. It's a very difficult issue still.
Thank you. Thank you, Kevin, for your question. Other questions? So I think there is no more questions. So thanks again, Giedre, for your presentation. It was very interesting. We'll talk later in another meeting. Thanks for your question and for following the seminar at SystemX. And I wish you a very good day.
Thank you, gentlemen. Thank you, everyone. Really, it was my pleasure to be here. And like I said, if you have any further questions, just send me an email. I'll be always happy. If I can help, I can give ideas, so we can discuss. I will be very happy for that. So thank you.
Thank you.